Happy Monday morning. So hopefully you followed along with the notes. We have our systematic savings formula. As such, F equals D times, in parentheses, notice that I've got an extra set of parentheses. My square brackets just go together, saying that's the entire thing in the top. Those brackets go together. Those brackets go together, so everything in the bottom. We've got F is our final or future amount. D is the regular deposit amount, how much you're putting in every single time period. R is going to be your interest rate. N is going to be the number of annual deposits, so how often you deposit money, how often you put it in. For us, the number of annual deposits is always going to be equal to the rate at which interest is compounded. So if it's something says interest compounded monthly, that means we are depositing 12 times per year. If we are saying we are paying weekly, then that is going to be interest is compounded weekly. So those two are always going to line up, the compounding and the number of annual deposits. Lastly, time is in years. Pay attention to our units. Time is always in years. So we're going to do a couple examples working with the examples that go through the notes. So you just saw that in order to retire, if you need so much money, you would need about, what was it, $100,000 just starting off right now if you plan on retiring in 45 years. Well, that is ridiculous. I certainly don't have that, and I don't want to wait until I can figure that out. So what happens if we set aside a little bit of money each time? That's where this future value comes in. Our systematic savings, this repetitive savings amount comes into play. So the example that we have in the notes, the first example, we're going to save $200 a paycheck. We're going to assume that we have 26 paychecks per year. We're going to do this for 45 years, so starting now, about 20 years old until we're 65. 5% compound interest. What's our final amount going to be? Do we need $100,000 right now in order to retire in 45 years? Or is there a better way to do it? So, reading for the information that we have a deposit amount of $200 per paycheck. We are getting paid 26 times per year. That's bi-weekly. That's reasonable for most of us. Our time is going to be 45 years. We have compound interest of 5%, and we are looking for our final amount. So as usual, I go through and I write in what I know, what I don't know, filling into the formula. We've got F equals our deposit amount, 200. Now, I'm being careful with my brackets, just writing things out so I don't miss anything, and then I will transfer this into the calculator. Common is to miss that, subtract 1 in there. Be careful with that. Be careful in the calculator. All divided by 0.05 or 26. So now it is just a straightforward application in the calculator. If we put this into the calculator exactly as it says, being careful if we need brackets around the exponents, we can just plug it in at once and see our final outcome. So if we save $200 every paycheck, two parentheses, be careful with your exponent. Make certain that if you have the caret in there that you put parentheses around 26 times 45. I do not need that because I have the little box in there. Plug everything in. $880,594.82. So if you start saving $200 a paycheck right now, I realize that's high school, college, maybe not so much, but right out of school, if you start saving some money, long time from now, you're going to be making bank. Then you can always up it too as you start getting paid a little bit more. So there is our systematic savings formula, $880,594. That's not too bad. Let's try another one. All right. This goes with example 2 in the notes. Save $400 per month. So we have a deposit amount of $400 per month. Our N value is 12. In an account earning 3% compounded interest, our R value is 0.03 for 10 years. T equals 10. So using the formula, we have F equals Everything's on one side of the equation. I can plug everything into the calculator at once. So $400 per month for 10 years. We end up with $55,896. So far, so good. Straightforward, evaluating using the formula that we have, future amount, final amount, the regular deposit amount, interest rate, number of deposits or compounds per year. We've got, again, N shows up again. We've got the time in years. There's this -1 that's left over from the derivation of the formula. You can check back to the notes. Hopefully we've read through that, or you can check out the textbook, or we'll talk about it later. There's our future amount. Certainly we label that appropriately. Now there's one more thing that we're going to do today. We've solved for the final amount. We've used the formula. The other thing is, if we know the final amount that we want, can we solve for the regular deposit amount? Can we work backwards, find how much do we need to pay each pay period? So that gives us example 3. Couple needs to save $200,000 for their child's education. If we've got an interest amount of 8% compounded quarterly, or we're going to make quarterly deposits, we're going to do that for 13 years. How much do we need to save each period of time? So we've got everything laid out. This goes along with example number 3 out of the notes. Plugging things into the formula, I'm just going to write it out once again. You see, we've got 200,000 equals our deposit amount. What I see here is we have everything on one side of the equation multiplied by the d value. So what we can do is we can evaluate this entire statement in the calculator at once, and then we'll divide that to the other side. So we'll have 200,000 divided by this value. Plug that into the calculator, see what we get from the start. So it comes up 90.0164. I'm going to keep at least 3 decimal places. This gives us 200,000. That becomes multiplication, so we will divide to the other side. We have D. And we see that we need to save $2,221.82 every quarter in order to amass $200,000 in 13 years. Or it's every 3 months, $700 a month if you want to save for your child's education. Be a little bit more appreciative of your parents now. That's what we got for today. Tomorrow we're going to solve for time. So long.